This assessment asks us to predict the product of the reaction on screen. Note that the way this reaction is going to start is we're going to take our carboxylic acid, add a base, which means we'll be deprotonating it to make a carboxylate, and then we're going to react that carboxylate with the acid chloride. We know that the acid chloride is the most reactive of our carboxylic acid derivatives, so when a carboxylate reacts with it, we should get an efficient reaction to make an anhydride. Let's look at the mechanism of the reaction as we always do. Now, I'm not going to show the mechanism of the first step, except to say that we're going to deprotonate the carboxylic acid to make our carboxylate. That carboxylate, as a negatively charged nucleophile, should be somewhat reactive, especially when we're reacting it with an acid chloride, one of the most reactive carboxylic acid derivative functional groups. And so having deprotonated that oxygen, we now have our good nucleophile. It can attack the carbon of the acid chloride, pushing the electrons up to make our tetrahedral intermediate. So we'll draw that tetrahedral intermediate here. Oh, bad triangle. We now have a negative on oxygen. We have our chlorine as our good leaving group, and then the rest of the molecule comes along with it. At this point, the tetrahedral intermediate can collapse, these electrons going down to reform the carbon-oxygen pi bond and kicking out the best leaving group, which in this case is the chloride. This is going to give us the final product, anhydride. Note that this reaction, at least from here, goes by that general mechanism 18A, where our nucleophile is strong enough to react directly. Nucleophilic addition makes the tetrahedral intermediate. Collapse of the tetrahedral intermediate gives us our final product.